What if I told you that every tire change you've ever done has probably damaged your vehicle? Not because you're incompetent, but because you've been deliberately kept in the dark about the proper techniques. Those lug nuts you've been cranking down with all your strength? You're creating microscopic stress fractures in your rims every single time. The impact gun at the shop that sounds so professional? It's over-torquing your wheels and warping your brake rotors. And they know it. This systematic miseducation isn't an accident. It's a carefully orchestrated revenue stream built on your mechanical ignorance. The real tire-changing techniques, the ones that protect your rims and extend component life, are treated like classified information. Today, we're breaking that code of silence. Stick around because I'm about to reveal the tire maintenance secrets that have been locked away in professional garages for generations. The tire industry thrives on the idea that wheel maintenance is a mystical art and only they hold the sacred knowledge to proper installation. But what if I told you that you could not only master these techniques, but also protect your expensive rims using nothing more than basic tools and forbidden knowledge that's been hidden from you? We're talking about the kinds of devastating mistakes that make your wheels weaker, more damaged, and less reliable with every single tire change. These are the errors that are considered normal in the DIY world, but they're slowly destroying thousands of dollars worth of equipment. These mistakes aren't just about convenience. They're about your wallet and your safety. Every cross-threaded lug stud, every over-torqued nut, every improperly seated wheel is costing you hundreds in premature replacements and potentially putting you at risk. Wheel damage isn't a matter of bad luck. It's a choice. A choice you make every time you change a tire through proper technique or destructive ignorance. You've been led to believe that tight enough is good enough, fueling an endless cycle of rim replacements and alignment issues. But what if I told you that this cycle can be broken? That master technicians who work in professional race shops use specific protocols to protect million-dollar wheel sets. And none of this knowledge requires expensive equipment. The most experienced tire technicians, those who work on Formula One cars and high-end exotics, use precise techniques to ensure wheels last decades, not years. These methods, passed down through generations of professionals, aren't complex procedures. They are applied engineering, simple protocols that protect your investment and prevent costly damage. Today, we are going to pull back the curtain on these industry secrets. I'm going to reveal the 10 most destructive tire-changing mistakes that have been bankrupting car owners for decades for one very simple reason. The more wheels you damage, the more you buy. And you know what that means for tire shops and wheel manufacturers? Pure profit. We are about to embark on a journey into the hidden world of professional wheel maintenance. A place where standard DIY procedures are thrown out the window in favor of techniques that actually protect your equipment. This is the stuff tire shops pray you never discover. The 10 mistakes that are slowly destroying your rims every time you change a tire. If that sounds like the kind of knowledge you want in your own garage, then do yourself a favor right now. If you appreciate information that actually saves you thousands and gives you professional-level skills, then show your support by hitting the like button and subscribing. It's a small click for you, but a huge signal for us to keep exposing the automotive secrets that truly matter. The damage stops here and now, because mistake number 10 is going to completely change how you approach wheel maintenance. Starting at number 10, using cheap or damaged impact guns. Did you know that low-quality impact wrenches have completely erratic torque delivery? Most Harbor Freight specials can vary by 40-50 foot-pounds between identical settings. That's the difference between proper installation and wheel destruction. When you think about it, that impact gun you picked up on sale for $49.99 is being trusted to properly secure components that keep your 2-ton vehicle safely on the road. It's literally a life-or-death tool, yet most people treat it like any other garage gadget. You see that satisfying rat-a-tat-tat sound your impact gun makes? That's not efficiency. That's your tool literally hammering your wheel studs and lug nuts with uncontrolled force. Professional shops calibrate their guns monthly and use torque sticks for a reason that the tool industry doesn't want you to know. Here's what's actually happening. Each impact creates a microsecond of extreme force, well beyond what your wheel components were designed to handle. The hammer mechanism inside a cheap impact gun doesn't deliver consistent torque. It delivers random spikes of force. Think of it as hitting your lug nuts with a sledgehammer instead of tightening them with precision. The illegal secret is that you can achieve professional results with a simple torque wrench and some patience. Pros install wheels by hand threading first, then using a star pattern with gradually increasing torque, never with an uncalibrated impact gun. Even high-end impact tools are only used to spin off or initially thread components, never for final tightening. That part is always done with a calibrated torque wrench. It might take an extra 2 minutes, but those 2 minutes save thousands in damage. You've been conditioned to believe that faster and louder means more professional. But you're actually gambling with your wheels every time you pull that trigger. The constant hammering effect isn't just damaging your hardware, it's weakening the molecular structure of your wheel studs with each application. Remember those lug nuts that seem to get progressively harder to remove with each tire change? That's not coincidence. It's the compounded damage from improper torque application. The threads are being slowly deformed with each impact, creating a downward spiral of increasing damage. And the shops that use impact guns for everything, they're not doing it for quality. They're doing it for speed and profit. Every minute saved equals another vehicle serviced and another invoice generated. Your wheel's longevity is literally being sacrificed on the altar of efficiency. The proper approach is simple. Use your impact gun only for initial removal and replacement, never for final tightening. Get a quality torque wrench, learn your vehicle's specific torque values, and take the extra time to do it right. Your wheels and wallet will thank you. But if you think improper tools are bad, wait until you see how the wrong tightening sequence is silently warping your expensive alloys. Number 9. Skipping proper torque sequence. Here's a staggering reality. Most DIYers just go clockwise around the wheel, thinking they're being methodical. But this seemingly logical approach creates asymmetric clamping that can literally bend lightweight alloy wheels. Let me paint this picture. Imagine putting a piece of paper on a table and pushing down on just one side. What happens? The paper deforms unevenly. Your expensive alloy wheel reacts the same way when you tighten in a simple circular pattern. The side you tighten first experiences excessive clamping force while the opposite side remains relatively loose. That simple clockwise pattern you've been using? It's concentrating stress on one side of the wheel before the opposite side is properly seated. The result is microscopic warping that compounds with every tire change until your expensive alloys are permanently damaged. The physics here is undeniable. As you progressively tighten in a circle, you're essentially pulling the wheel toward the first lug you tightened, creating an off-center mounting position. This off-center mounting creates lateral runout, a fancy way of saying your wheel isn't perfectly perpendicular to the hub anymore. Professional technicians always use a star pattern, gradually stepping torque in stages. 50%, then 75%, then 100% of specification. This ensures even clamping force distribution and prevents stress concentration. Picture a wheel as a clock face. After tightening the 12 o'clock position, you'd move to 6, then 3, then 9, and so on. This balanced approach ensures that the wheel seats evenly against the hub, preventing the warping that leads to vibration, uneven tire wear, and eventually, cracked alloys. And here's where it gets even more detailed. Proper tightening isn't just about pattern, but also about progressive force application. The first pass should be light, just enough to seat the wheel. The second pass increases to about 75% of specification. Only on the third pass do you reach full torque, and always following that same star pattern. What's truly insidious about this mistake is that the damage isn't immediately visible. Your wheel doesn't crack in half the first time you use a circular pattern. Instead, it's subjected to imperceptible warping that, over dozens of tire changes, weakens the structure until failure becomes inevitable. You've been taught that any systematic approach is sufficient, but the sequence matters as much as the final torque value. The auto industry has been content to let you believe that tight is right, when the reality is that the path to tight is just as critical as the destination. Next time you change a wheel, take the extra 30 seconds to use a proper star pattern. Start opposite the valve stem and work your way in a star pattern, gradually increasing torque with each pass. This simple change in technique costs you nothing but saves your wheels from premature failure. Think the torque sequence is critical. Wait until you see how mixing the wrong hardware is creating time bombs on your vehicle. Number 8. Mixing wheel hardware and using wrong lug types. This is where the parts industry makes a fortune off your confusion. Conical, ball seat, and flat seat lugs are engineered for specific wheel designs, but most people just grab whatever fits the threads. I've seen countless DIYers and even professional shops commit this cardinal sin, installing whatever lug nuts happen to be in the toolbox, as long as the threads match. But wheel hardware isn't interchangeable, and this fundamental misunderstanding is destroying your expensive wheels with every mile you drive. Using the wrong seat type doesn't just look unprofessional, it concentrates thousands of pounds of clamping force in the wrong area of your wheel. That mismatched hardware is literally creating stress cracks in your rim's bolt holes that will eventually cause catastrophic failure. Let me break this down. A conical seat lug nut is designed to create a specific contact point with the wheel, distributing force in a precise pattern. Use a flat seat lug on a conical wheel, and you've just changed that distribution completely, creating point loading that exceeds the wheel's design specifications. For example, installing ball seat lugs on a wheel designed for conical seats means that instead of spreading the load across the angled surface of the lug hole, all that force is concentrated on a tiny ring of contact. Over time, this mismatch causes the wheel material to deform, creating microscopic fractures that spread with every thermal cycle. The forbidden knowledge is simple. Always match lug seat type to wheel design. Check your manual or consult a professional before swapping hardware. This isn't an area for experimentation. And here's an industry secret. Those universal lug nuts with the swiveling washers that claim to work with any wheel? They're a compromise at best and potentially dangerous at worst. They create uneven seating and can loosen over time due to the additional moving parts. They're a convenient solution for wheel shops, not for wheel longevity. What's worse, many aftermarket wheels come with their own specialized hardware that's engineered specifically for that wheel's metallurgy and design. Using generic replacements negates all that engineering and puts your expensive investment at risk. You've been led to believe that close enough is acceptable when it comes to hardware compatibility, but precision matters when dealing with structural components. Your wheels are quite literally hanging on by a thread, the threads of your lug nuts and studs, and that connection deserves proper respect. Next time you need replacement lug nuts, take the extra step to verify the correct seat type for your specific wheels. The difference in cost is minimal, but the difference in wheel protection is substantial. Do you think using the wrong lug type is bad? Just wait until you hear why skipping the crucial retorque step is costing you hundreds in hidden damage. Number 7. Neglecting to retorque after the first 50-100 miles. Even when you do everything perfectly, alloy wheels undergo thermal cycling as they heat up and cool down. Most people think the job is done once they drive away, and that assumption costs them hundreds. This might be the single most ignored professional practice in wheel maintenance. Every high-end shop and race team in the world requires a retorque after initial installation, yet almost no DIYers and few quick lube places ever mention it. There's a reason for this silence, and it's not because the step is unnecessary. That settle you feel in new wheels isn't your imagination. As aluminum expands and contracts through temperature cycles, it actually changes the clamping relationship. Skip the retorque, and you get micro-fretting between wheel and hub that gradually ovals your bolt holes. Let me explain what's happening. When you first install a wheel, everything seems solid. But after driving, the entire assembly heats up from brake friction and road contact. Different materials, aluminum wheels, steel hubs, steel lug nuts, expand at different rates. As they cool down, these components contract differently as well, slightly changing the initial torque values. This thermal cycling is completely normal, but it requires compensation. What was perfectly torqued in your driveway may be 10–15% looser after the first heat cycle. That slight looseness creates microscopic movement between the wheel and hub, movement that wears away material with every rotation. Professional installers always schedule a retorque check after the first heat cycle. It takes 5 minutes and can save your wheel from permanent damage. This isn't over-caution. It's applied metallurgy. The wheels on high-performance vehicles like Porsches and Ferraris aren't magic. They're subject to the same physical laws as your daily driver. The difference is that these vehicles get maintained with proper protocols that respect material science. You've been conditioned to think that properly torqued means permanently torqued. But thermal cycling changes everything. It's like expecting a brand new suit to fit perfectly without alterations. The real world requires adjustments that theory doesn't account for. The next time you install wheels, make a reminder to check the torque after 50-100 miles of driving. You'll often find that even with perfect initial installation, several lug nuts have slightly loosened. This simple 5-minute check can double the lifespan of your wheels by preventing the cycle of damage that begins with that first uncompensated thermal cycle. If you want to be truly professional, mark one lug nut with a small dot of paint after initial installation. If that mark moves after the first drive, you've just witnessed thermal settlement in action. Concrete proof that retorquing isn't just shop talk, but critical protection. Think skipping retorquing is bad? Just wait until you see how lifting your car incorrectly is silently destroying its structural integrity. Number 6. Lifting at the wrong jack points. This mistake is so common that most people don't even realize they're doing structural damage every time they change a tire. Placing your jack under suspension arms or random pinch welds seems logical, but it's systematically destroying your vehicle's geometry. I see this constantly. People positioning jacks wherever seems convenient or stable, completely unaware that they're potentially causing thousands in damage with each lift. Modern vehicles have specifically engineered lift points designed to distribute weight properly, and they're rarely where you think they are. Every time you jack up your car incorrectly, you're bending structural points and throwing wheel alignment off by millimeters. That sounds minor, but those tiny changes create premature tire wear and rim stress that compounds over time into major problems. When you place a jack under a control arm or random frame section, you're not just lifting the car, you're potentially deforming components designed to flex under driving conditions, not support the vehicle's entire weight. These components have precise geometry that affects everything from steering feel to suspension travel. The manufacturer-specified jack points exist for a reason. They're designed to handle lifting forces without deformation. Check your manual and invest in proper jack point adapters if necessary. Most vehicles have reinforced lift points with specific pads or notches engineered into the frame. They're positioned to balance the vehicle's weight and protect critical components. Using these points isn't just a recommendation. It's essential to maintaining your vehicle's structural integrity. For example, lifting a unibody vehicle by the pinch welds seems logical because they appear strong, but unless you're at the factory-specified points with the proper adapter, you're likely creating tiny bends in the sheet metal that affect door alignment and water sealing. Over time, these minor deformations can even lead to premature rust as water begins pooling in areas it shouldn't. You've been taught that any solid point under the car is sufficient for lifting, but structural engineering doesn't work that way. Every part of a modern vehicle is designed with specific load parameters in mind, and exceeding those parameters even briefly has consequences. The solution is simple. Locate your vehicle's designated lift points, check the owner's manual if you're unsure, and use the proper adapters to distribute force correctly. For regular tire changes, this small adjustment in technique prevents accumulated damage that can affect everything from ride quality to resale value. Lifting mistakes can bend your car's frame, but they're nothing compared to the destruction caused by cross-threading lug studs. Number 5. Cross-threading or over-threading lug studs. In the rush to get back on the road, most people start threading lugs with their impact gun or just force them on. But once you cross-thread even a single turn, you've potentially ruined both the stud and the nut permanently. I've seen even professional mechanics make this critical error, placing the lug nut against the wheel and immediately hitting it with the impact gun. That first half second determines whether your wheel components will thread properly or begin a destructive spiral that ends in expensive repairs. Cross-threading creates a cascade of problems that the repair industry loves. Damaged threads force wheel misalignment, which leads to vibration, which creates stress fractures, which eventually require hub replacement. One careless moment becomes hundreds in repairs. Let me walk you through the physics. A properly threaded connection distributes force evenly along the entire thread engagement. Cross-thread even slightly, and that distribution becomes highly uneven, creating stress concentrations that weaken both the stud and nut. Add normal driving forces, and these weak points become failure points. What's worse, cross-threaded connections often feel tight when they're anything but secure. The false sense of security masks a dangerous reality. Your wheel is quite literally hanging by damaged threads that could fail catastrophically under load. Professional technicians always start every lug nut by hand until they feel it seat properly. Only then do they apply tools. This extra 30 seconds prevents thousands in potential damage. The proper technique is simple. Place the lug nut against the wheel, rotate it counterclockwise until you feel a slight click as the threads align, then turn clockwise by hand, for at least 2 complete revolutions before using any tools. This ensures proper thread engagement and prevents the cascade of problems that begins with cross-threading. For those stubborn lug nuts that seem to fight proper threading, check for debris or damage on both the nut and stud threads. Sometimes a simple cleaning with a wire brush is all that's needed to restore proper function. Never force a lug nut that doesn't thread smoothly. It's a warning sign you should heed. You've been pressured to believe that speed matters more than precision, but thread damage is irreversible. Once you've cross-threaded a stud, that damage becomes permanent, gradually worsening with each installation attempt until complete failure occurs. Remember, those threads are the only things keeping your wheel attached to your vehicle. They deserve the respect of proper installation, not the rush of convenience that leads to expensive repairs. Thread damage is insidious, but it's nothing compared to how anti-seize compounds are being catastrophically misused. Number 4. Completely misunderstanding anti-seize compound. Here's where the chemical industry has created profitable confusion. Most people either skip anti-seize entirely, causing wheels to weld to hubs, or slather it on everything, which completely changes friction values and throws off torque readings. This is truly one of the most misunderstood aspects of wheel installation, with zealots on both sides of the debate. Some swear by coating every surface liberally, while others avoid it entirely, fearing contamination. The truth, as usual, lies in precise application based on material science, not folklore. Dry mounting can literally weld your wheel to the hub over years through galvanic corrosion. But too much anti-seize creates a slippery interface that makes properly torqued lugs feel loose. Both approaches destroy your wheels through different mechanisms. When dissimilar metals contact in the presence of moisture, like aluminum wheels on steel hubs, galvanic corrosion begins immediately. This electrical reaction literally bonds the components at a molecular level, making future removal difficult or impossible without damage. This is why wheels left mounted for years often require destructive removal techniques. However, apply anti-seize improperly, and you've created an entirely different problem. These compounds significantly reduce friction. That's their purpose. But torque specifications are based on dry friction values. A properly torqued lug nut with anti-seize on the threads can be over-torqued by 20–30% due to this reduced friction, causing stress beyond design limits. The precise technique: apply a light, even smear only on the hub center lip, never on lug threads unless manufacturer approved. This prevents corrosion without affecting torque accuracy. Some premium European manufacturers actually recommend specific anti-seize compounds for specific locations. They understand that the hub-to-wheel interface needs corrosion protection, but the threaded connections require dry assembly to maintain proper torque relationships. For optimal results, clean both surfaces thoroughly. Apply a paper-thin layer of appropriate anti-seize to the hub center only, and assemble with clean, dry fasteners torqued to specification. This balanced approach prevents both corrosion welding and torque inaccuracy. You've been given the false choice between none and lots, when the answer is precise application in specific locations. This nuanced approach isn't profitable to teach because it requires education rather than product sales, so the industry perpetuates the extremes. Remember, anti-seize is a precision tool, not a cure-all. Used correctly, it prevents expensive damage and makes future service easier. Used incorrectly, it creates the very problems it's meant to solve. The difference is in the details that professionals understand and apply with every installation. Misusing anti-seize can cause major problems, but it pales in comparison to the invisible damage caused by dirty mounting surfaces. Number 3. Failing to clean hub and wheel mating surfaces. This is the most overlooked step in wheel installation, and it's costing drivers thousands in vibration-related damage. Even microscopic brake dust and corrosion buildup prevents proper wheel seating. This silent destroyer operates completely beneath your awareness. You can't see it happening, but with every rotation, that tiny bit of contamination between your wheel and hub is doing permanent damage to both components. What looks clean to the naked eye can still harbor enough contamination to prevent proper mating. When your wheel can't sit flush against the hub due to contamination, it creates lateral runout that translates to steering wheel vibration and uneven torque distribution. Over time, this damages the rim center bore and creates permanent wheel imbalance. Think about this. A human hair is about 70 microns thick. As little as 50 microns of contamination, thinner than a human hair, between your wheel and hub can create measurable vibration at highway speeds. That vibration then creates a feedback loop of increasing damage as components wear unevenly. The physics is undeniable. Any gap between the wheel and hub transforms from a static problem into a dynamic one once you're moving. That microscopic space allows the wheel to move in ways it was never designed to, creating force multiplication that accelerates wear exponentially. Professional shops use wire brushes and hub cleaner pads on every installation, not just when things look dirty. Clean mating surfaces are mandatory for proper wheel function, not optional for appearance. The proper technique is thorough. Use a proper hub cleaning tool to remove all rust, corrosion, and brake dust from the hub face. Clean the wheel's mounting surface as well, paying special attention to the center bore and lug holes. This comprehensive approach ensures truly flat mating surfaces that prevent vibration-inducing runout. For severely corroded hubs, more aggressive cleaning may be necessary. Some professionals even use specialized hub resurfacing tools to restore the original flat surface. This level of attention might seem excessive, but it's the difference between wheels that last and those that develop premature problems. You've been led to believe that visible cleanliness is sufficient, but surface contamination works at the microscopic level. The human eye simply can't detect the scale of problems that affect proper wheel mounting, which is why professionals rely on process rather than visual inspection. The next time you change wheels, take the extra 2 minutes to properly clean all mating surfaces. It's a small investment that pays enormous dividends in wheel life and performance. Your steering will feel more precise, your tire wear will improve, and your wheels will maintain their integrity far longer. Dirty mounting surfaces cause invisible damage, but using the wrong tools is visibly destroying your expensive lug nuts. Number 2. Using wrong sockets or worn impact sockets. Here's a costly reality most people discover too late. That socket set you've been using for years is systematically destroying your lug nuts and wheel finish. Sloppy, worn, or non-impact sockets chew nut edges and gouge wheel surfaces every time you use them. Look closely at the lug nuts on most vehicles with a few years of service, and you'll likely see rounded edges, chewed corners, and surface damage. This isn't normal wear, it's the direct result of improper tools used for installation and removal. Once this damage begins, it compounds with each service until the nuts become nearly impossible to remove. Those convenient chrome-plated sockets, they crack under torque and transfer that stress directly to your lug nuts. Meanwhile, standard sockets are too thick to properly seat over many lug nuts, causing edge damage that makes future removal difficult or impossible. The metallurgy matters. Chrome sockets are designed for general use, not the high-torque application of wheel service. When these sockets reach their stress limit, which happens frequently with lug nuts, they develop microscopic fractures that transfer damage to your hardware before failing completely. Standard deep sockets also have walls that are too thick for proper clearance on many wheel designs. This poor fit forces the socket to contact only the corners of the lug nut, not the flat sides as designed. The result is concentrated force that rounds those corners with each use, gradually transforming hexagonal nuts into useless circles. The forbidden knowledge: thin wall impact sockets that properly seat over lug nuts without interference. They're designed to handle torque loads without failing and transferring damage to your hardware. These specialized sockets have walls precisely engineered for wheel service, with enough clearance to fully engage the lug nut without contacting the wheel surface. The difference in fit is dramatic, and so is the reduction in hardware damage over time. For chrome-plated or decorative lug nuts, the situation is even more critical. These require socket protectors or specialized tools designed specifically for their finish. Skip these protective measures, and you'll be replacing those expensive nuts after just a few services. You've been sold the convenience myth that any socket that fits will work. But precision tooling exists for a reason. The small investment in proper wheel service tools pays for itself the first time you avoid replacing rounded lug nuts or repairing gouged wheel finishes. Remember, your socket is the interface between your force and your fastener. That interface should transfer power efficiently without causing collateral damage. Anything less is literally throwing money away with every tire change. Wrong sockets damage your hardware, but our #1 wheel-killing mistake is something almost everyone does without a second thought. So you've made it this far. You clearly care about protecting your wheels and doing things the right way. But before I reveal the single most destructive mistake that's costing car owners thousands in needless damage, I need to ask a favor. If this information is helping you understand the hidden techniques that protect your investment, take a second to hit that like button and subscribe to the channel. We're fighting an uphill battle against decades of misinformation, and your support helps us reach more people with these industry secrets. In the comments, I want to hear your opinion. Do you think tire shops deliberately avoid teaching these techniques to keep you coming back for replacements? Or is it just ignorance passed down through generations of undertrained technicians? Your perspective helps us understand what topics to cover next. The final mistake we're about to discuss is so common and so destructive that exposing it might actually change the way the entire industry operates. And trust me, they don't want that to happen. And the #1 mistake destroying wheels across the country: over-torquing lug nuts. This is where decades of tighter is safer mentality has cost drivers millions in wheel and brake damage. Factory torque specs exist for a reason, typically 80-100 ft-lbs for passenger cars. But most people think cranking harder provides extra security. The psychology here is fascinating. We instinctively equate tightness with safety. It feels inherently wrong to leave something loose when it's responsible for keeping our wheels attached. This primordial fear overrides the engineering reality that precise torque is about balance, not maximum force. When you exceed those specifications, the clamping force literally distorts your rim's mounting face and warps brake rotors. Every extra foot-pound of torque is reshaping expensive components in ways they were never designed to handle. The tire industry knows this and profits from the replacements. The physics is irrefutable. Metal stretches under load. Exceed the design parameters, and that stretch becomes permanent deformation. When you over-torque lug nuts, you're not just tightening them. You're physically stretching the wheel studs beyond their yield point, permanently weakening them with each installation. The damage doesn't stop with the studs. Excessive clamping force distorts the wheel's mounting face, creating high spots that prevent proper seating. These high spots then create hot spots during driving that expand and contract at different rates, eventually leading to stress cracks around lug holes. For brake rotors, the situation is equally dire. Over-torqued lug nuts can actually warp the rotor's mounting surface, creating lateral runout that manifests as brake pedal pulsation. What started as a simple case of over-tightening eventually becomes an expensive brake service that could have been completely avoided. Master technicians always use calibrated torque wrenches, never impact guns for final tightening. They understand that proper torque is about engineering precision, not muscular force. The correct technique protects both wheel and brake components. The solution costs about $30, a simple beam-type torque wrench that provides accurate readings without complex mechanisms to fail. This basic tool, combined with your vehicle's factory torque specifications, prevents the cascade of damage that begins with over-torquing. For those without torque wrenches, There's a crude but effective emergency technique. Tighten the lug nuts until they're snug, then add approximately a quarter turn. This won't provide perfect torque, but it's far better than the gorilla tight approach most people use instinctively. You've been programmed to believe that mechanical strength equals safety. But over-torquing is the leading cause of preventable wheel damage in amateur installations. It creates the very problems you're trying to avoid, weakening the connection between wheel and vehicle while setting up a cycle of escalating damage. The next time you install wheels, fight the urge to crank those lug nuts as tight as possible. Instead, invest in a proper torque wrench and apply exactly the force specified by your vehicle's manufacturer. Your wheels, brakes, and wallet will thank you for this simple act of mechanical restraint. And there you have it, the 10 deadly mistakes destroying wheels across the country every single day. These aren't complex engineering concepts or specialized techniques requiring years of training. They're simple adjustments to common practices that can save you thousands in unnecessary damage and repairs. What tire-related topics would you like to see covered next? Drop your suggestions in the comments below, and don't forget to subscribe for more automotive truths the industry doesn't want you to know. Drive safe, and I'll see you in the next video.